Imagine, billions of years ago, a vast, cold, and empty stretch of space, silent, devoid of life, yet teeming with the potential for something extraordinary. Here, at the edge of our galaxy, in a quiet corner of the Milky Way, a storm was brewing. It wasn't the kind of storm we're used to, the kind that shakes the earth with thunder and lightning. No, this storm was made of dust, gas, and the invisible forces that govern the cosmos. In this vast nebula, a mixture of hydrogen, helium, and heavier elements from the remnants of long-dead stars gathered. These particles, each a tiny speck of matter, were about to undergo a monumental transformation. A disturbance, whether it was a nearby supernova explosion or the subtle forces of gravity, work set this cloud of gas into motion. Slowly, gravity began to pull the particles closer together, causing the cloud to collapse inward. As the dust and gas condensed, a gravitational tug-of-war began, pulling matter tighter and tighter. As this cloud collapsed, it began to spin. Think of a figure skater pulling in their arms to spin faster. The same thing happened here. As the gas cloud contracted, it spun faster and faster. This spinning motion caused the material to flatten into a disc shape. At the center of this disc, the matter began to concentrate, creating a dense, hot core that would eventually become the Sun. While the core of the nebula heated up, the outer parts of the disc cooled, forming small clumps of dust and ice. These clumps collided with each other, sticking together, slowly building up larger and larger objects. These objects, known as planetesimals, were the building blocks of planets. Some were small and insignificant, while others grew larger and larger, accumulating more matter through collisions and gravity. As the planetesimals grew, they started to influence each other. Some of these young bodies collided, forming larger objects, protoplanets. The gravity of these growing protoplanets pulled in even more material, so powerful that it began to dominate the solar system's early landscape. This protoplanet would become our Sun, the fiery heart of our solar system. While the Sun was forming at the center of this spinning disk of dust and gas, the other planetesimals were not idle. They too were growing, but their paths were shaped by the forces of gravity. As the Sun grew hotter and the surrounding disk of gas and dust began to cool, something remarkable happened. In the inner part of the disk, the temperature was too high for volatile materials, like water and methane, to condense into solid forms. So, in this inner region, the planets that formed were rocky, formed from heavier elements that could withstand the extreme heat. These rocky planets, or terrestrial planets, included Mercury, Venus, Earth, and Mars. As the planetesimals in this region collided and merged, the young planets began to take shape. They were small at first, but as they collided and merged, they grew larger and larger, each one vying for dominance in the early solar system. Through this violent process of collision and accretion, the core of each planet began to form, surrounded by a mantle and crust. But in the outer regions of the disk, the story was different. Here, the temperatures were much cooler, allowing gases like hydrogen and helium to condense into solid and liquid forms. These outer planets, the gas giants, Jupiter, Saturn, Uranus, and Neptune, formed from the lighter elements that were abundant in the outer solar system. These planets grew massive, gathering vast amounts of gas and ice, and as they grew, they captured even more material from the surrounding disk. The process of planet formation was far from smooth. The young solar system was a violent and chaotic place. There were countless collisions between planetesimals, and even between the young planets themselves. Some of these collisions were so intense that they sent massive shockwaves through the system, and in some cases, they shattered planets or formed moons. The Earth, for example, likely formed its moon from a massive impact with a Mars-sized object. This collision not only changed the trajectory of Earth's development, but also created a moon that would play a crucial role in stabilizing Earth's rotation and supporting life. Meanwhile, the inner rocky planets were continuing to grow, while the outer gas giants were becoming more massive, forming their own systems of moons and rings. Jupiter, the largest planet, began to act as a gravitational powerhouse, pulling in material from the surrounding space, and in the process, clearing out the debris left behind by the planet-forming process. The entire process took millions of years, and over time, the solar system took its current shape. For inner rocky planets, a series of gas giants with moons, and a vast outer expanse of icy bodies in the Kuiper Belt and beyond. But it was only after these planets were formed that the Sun itself began to reach its full potential. As the sun continued to heat up, it began to radiate more energy. This energy influenced the development of the planets, particularly those closest to it, Earth. The third planet from the sun began to cool, forming a solid crust. Volcanoes erupted, releasing gases into the atmosphere, and water began to condense, forming the oceans. This process, called planetary differentiation, allowed Earth to become the hospitable planet we know today. But even as the planets were forming, the solar system wasn't a peaceful place. Asteroids, comets, and other debris continued to bombard the young planets. Many of the craters on the Moon and Mars are evidence of these violent impacts. The solar system, though stable in its overall structure, remained a chaotic environment for billions of years. Yet, against this backdrop of cosmic violence, Earth would eventually become the cradle of life, and the Sun would become the steady, life-giving force that powers everything in our solar system.